Good afternoon. So we're going to discuss the derivation of the transfer function of the simple circuit with four components. Okay, so for our given circuit here, we have 5 ohms plus 5 ohms and 3 farad and 3 ohms and 2 Henry. Okay, and we have our variable uh, IT, and of course the voltage drop across these components are also unknown values. So to solve for the transfer function, we need to write the equivalent uh, Laplace circuit, no, of the given circuit. That is for the shortcut method. Okay, so this is now the equivalent Laplace equivalent circuit, wherein the 5 ohms is now 5 and the 3F is now 1 over 3S, and the 3 ohms is 3 and the 2H is 2S. And of course the VIT is equals to VIS, the IT is IS, and the VLT is now VLS. Now the KVL of the given simple circuit is equal to VIS is equals to voltage drop at 5 ohms, voltage plus voltage drop with this, plus voltage drop with this, plus voltage drop with this. So that will give us this equation, wherein if we're going to um, factor out IS and convert IS into VLS over 2S, that is the Ohm's law, no, of IS at VLS. Okay, so from here we by algebraic manipulation, no, we get the least common divisor of the four terms, so that will be 3s. So adding 5 and 3, we're going to have 8. So 8 times 3s, that will be 24s, and then 3s times 2s, that will be 6s squared, and then the 1 here, okay, all over 3s. And multiplying 2s with 3s, so we get here 6s squared. And simplifying this further, we have okay, so if we transpose VLS over VIS to be our transfer function, no, the output over the input, then our fraction will be uh, 6s squared over 6s squared plus 24s plus 1. Okay, simplifying further, now dividing both the numerator and the denominator with 6, so we're going to have s squared. Okay, we have s squared over s squared plus 4s plus 1. So this is now our transfer function.